Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Professor Patel, and we are going to continue our chapter Velocity in Mechanism, and in this lecture we will study the example based on relative velocity method. Okay, let's start. Before starting the example of velocity in mechanism, we will revise some points we have learned in a previous lecture, because in this chapter there is no derivation or any formula. Totally example depends on the fundamental things we have learned in theories. Okay, so you know that first of all, first rule is that all fixed point will be at origin. So in example, in mechanism, whatever the points, number of points you see the which are fixed will be at the same point on a origin point. Okay, or in a velocity diagram. Second is the velocity of any link, any point on a link will be perpendicular to link. Third is the direction of slider always be the line of action passed through the origin point in a velocity diagram. I am going to explain you this again, because if the piston is moving in this direction, then you will draw the line passing through the origin. Okay, I'm giving you another example. If the slider is sliding some at position, some at angle is there, and it is sliding with this direction, so what you have to do in velocity diagram, you have to draw the line passing through the origin in direction of line of action of piston. Now you can understand that what is rule number 3. Direction of slider will be same as line of action. Its direction will be in this line, but it will pass through the origin point. Okay, and after that, last and fourth rule is the velocity of any point on a link. Means in for the velocity, if on a link you want to find the velocity of any point, you have to take this ratio between the space diagram and velocity diagram. Okay, let's start the first example of velocity in mechanism. So you can see here in a 4-bar chain mechanism, ABCD, AD is a fixed, AD is a fixed, so I can draw the AD here, and then its length is 150. Okay, the crank is a 40, crank here it is a 40, and rotate at a 120 rpm, 120 rpm, and link CD. Okay, AD, and there is a link CD directly given here. Okay, and oscillate about the D point. D point is here, and BC and AD are equal length. Okay, so this fourth link and this first link is a same length. Find the angular velocity of CD. Means we have to find the velocity of link CD. Angle of BAD is given. So first of all, we have to draw this whole mechanism. So check this dimension first. So length of all 4 links given here. Okay, because AD is equal to BC or 4. So we have to draw this with using this angle. So how can you draw this? This measurement is a 150 mm, and when you going to draw 150 means half foot, you can't draw in your norm. So you have to take the scale here and check this out. What you can take the scale means you want to descale, because 150 mm is higher, so you will take the scale as 1 mm is equal to 2 mm. So you will start with the AD. You draw the AD here. Okay, you will draw the AD, means length will be 7.5. Okay, 7.5. After that you will start with the AB. Angle is given here 120. Angle is given here 60. So you will take the protector and give the link length. Link length will be 20, because 40 is the original length, and we have take the scale 1 mm is equal to 2 mm. So we will draw the length line of 20 mm only. Okay, this is in a semi, sorry, 7.5 semi, so it will be 7.5 75 mm. So you will draw this diagram. Okay, this dimension is given is actual, but you will draw at a half size because we have taken the scale. Okay, so this will be 75, this will be 40, and this will be 20. Remember that student making mistake, they scale all points, means they divide this angle also and take the 30. No, we descaling the this geometry, but angle will be the same. Okay, now what we want to do, we want to make the velocity diagram. And in velocity diagram, remember that velocity is a one vector, and for this vector you need two things, magnitude and direction. Okay, magnitude and direction. You know the direction of every point in this mechanism. Why? Because direction, you already know that it is a perpendicular to link, perpendicular to link. So you can know the every direction from this mechanism. You don't know magnitude, so you can start the diagram so that always there is a given for the magnitude of any one element. So always you can find the magnitude of any one link. So in our case here, this RPM is given, RPM of this AB link is given, and using that RPM you can find the angular velocity. Okay, you can find the angular velocity, which is 2 pi n by 60. N is a RPM 120, and you can see here 12.56 radian per second. You have find the angular velocity, and you know the relation between angular velocity and linear velocity. So linear velocity will be angular velocity into length AB. So now you can see here 12.56 angular velocity, and length of link 0.04. Why the length is 0.04? There is a 40 mm, but you know the unit of velocity, meter per second. So that's why this 40 mm converted into meter means divided by 1000. So it will become 0.04. Okay, so what speed we have achieved here? Check this, 0.503 means velocity of this link, linear velocity is a 0.5. Now we are going to draw this in a diagram, but 0.5 is a very small quantity, so you can't draw the 0.5. Okay, so we have to scale, means enlarge this scale. So what can I take the scale? Check this, 0.5 meter per second. So I can take the 1 meter per second is equal to 100 mm. So you have taken the scale 1 meter per second is equal to 100 mm. So 0.503 meter per second, you have to multiply the scale 0.503 into 100, then your first distance or magnitude of velocity will be 50.3 mm. Okay, I will going to show you how you will draw the velocity diagram using this 4 rules. Okay, remember there are 4 rules. First of all, in mechanism you have to check this, which are the fixed point. You can see there is a point A and D is a fix. Okay, so in velocity diagram, first of all you will take the origin point and make the A and D, because you know that A and D is a fix, so all fix will be at the origin. So it is the origin point, this point. Okay, so after that you will consider this link AB, for which you know the velocity, okay, magnitude. So what you have to do, AB length, AB link velocity, for what will be the direction? You know the direction is always perpendicular to link, and here is given in this direction. Okay, so you have to draw the line from this in same direction, and length of this line will be 50.3 mm. So you will draw the line here, which length is a 50.3. Okay, and this point you will get is a b, small b. So that's how you have drawn the first vector, means velocity of AB, velocity of B with respect to A, and this is the first line you are making. And after that, what you have, you can do here, you want to know velocity of C with respect to B. How can you draw that? Check this, velocity of C with respect to B means that you know that the direction will be maybe in you know that the direction of this velocity, you can say maybe it is in this direction or maybe in this direction, but you sure that it is a perpendicular to that link. So first of all, in this direction you will make the line which is passing through the B. Okay, so you will make the line which is passing through the B, and it will be the in the same direction of this. In this direction you will draw this line here. Okay, you can roll here, or you can measure this angle and apply here, or you can use set square, and set square is a very simplest method for drawing this type of parallel lines here. And after that, check this out, what you have to do, you can see a velocity of C with respect to D. What will the direction? Maybe this is in this direction, or maybe in this direction. Okay, perpendicular to link. So you can draw the line from here perpendicular to that link, but from where? What? From this point here, D. You know the D here. D is here. So velocity of C with respect to D for CD link, you have to draw this line. Okay, so what you will do? You will draw the same line, means perpendicular to this link, same this line here, which is passing through the D. Okay, and after that you will erase unnecessary lines here from top, all these lines, and you will get this small triangle here, which is the velocity diagram for this mechanism. So how it is obtained, I am drawing, explain you again. Keep check this. So first of all, A and D. So at origin point you write both point here. After that, for AB link you have this data, small ab is equal to 50. So you will draw the 50, but in which direction? Perpendicular to this link, perpendicular to the link. So you will draw this AD, and length will be 50 here, 50.3. and after that you have completed this link and completed this link. Now you will start for the BC. So C point with respect to B, you will draw the vector perpendicular to link BC. What you will do, from B you will draw this line. Okay, you don't know the magnitude here, you only know the direction is a perpendicular to link. As per rule number 2, velocity of any point on a link will be always perpendicular to that link. So direction you know, so you will draw the whole line. You don't know the how much length should be there. Okay, so draw the full length line. Okay, and then with respect to D, you want to know the velocity of C. So what will you can do here? Again, what you will draw the line perpendicular to this link from what? From D. Okay, so you will draw this line here and full extended line. You don't know up to which, and when you intersect these two lines, you know that this is the point. This is the point which is C, because B velocity of C with respect to B is this line, and velocity of C with respect to D is this line. So this intersecting point is the C point, and you will erase the all extension here. Okay, and you will get this diagram. Okay, so when you indicating in this direction means for This is going to C. Okay, so velocity of C with respect to D. And if you are drawing same line but his arrow is in this direction, you have to write this velocity of D with respect to C. Okay, so what you want to measure? Velocity, angular velocity of CD. So you want to find the omega CD. Okay, and you can't find the omega CD directly. So first of all, you have to find omega velocity CD. And for velocity CD, what you will do? You will measure this line. You will measure this line here. Okay, you have to measure this CD line, measure it, and what you get? You get the length of this CD line. So you will get the length 38. Okay, in velocity diagram. But what is the scale? 1 meter per second is equal to 100 mm. So 38 mm is equal to 0.385 meter per second. Okay, so this will be the velocity of CD. And when you know the velocity of CD, you can find the angular velocity, because velocity is equal to m omega into CD. So omega is equal to velocity upon that length. Okay, that's it. This is a very practice required, very lots of practice, means lots of practice. Okay, this is the whole example. Lots of practice is required in velocity in mechanism, this type of example, because lots of variety are there. But you always remember that 4 rules, so you can complete any example from this chapter. Okay, thank you.